Hi, welcome back dear children to the class of chemistry. Last day we discussed about the non-metal nitrogen, right? Do you remember what we learned in that class? Yes, we studied about the percentage composition of nitrogen in atmosphere, the different ways in which the plants absorb nitrogen, advantages and limitations of organic and chemical fertilizers, and at last, the uses of nitrogen. Dear children, today we are going to discuss about the non-metal chlorine. In this video, you will learn about the laboratory preparation of chlorine, physical properties, bleaching action of chlorine, uses and identification of chloride salt. Are you ready? Well, haven't you seen bleaching powder used for water purification? Aren't you familiar with the smell of bleaching powder? What is the reason for its characteristic smell? Yes, it is due to the presence of chlorine. Chlorine is the major component of bleaching powder. So let's learn about chlorine and its characteristic properties. Chlorine was discovered by Carl William Scheele at 1774. The name chlorine was derived from the Greek word chloros, means pale green or greenish yellow. But it was Sir Humphrey Davy who confirmed and named chlorine to be an element. You all know that chlorine is a non-metallic element with a simple Cl. It is located in the period 3 at group 17. It is not seen in nature in free state due to its high reactivity. Do you know, in nature, chlorine is widely distributed over the earth in the form of salt NaCl in seawater. Typically, it combines with other elements and forms numerous compounds. Chlorine, chlorine dioxide, hydrogen chloride, potassium chloride, aluminum chloride, sodium chloride, etc. are some of the compounds of chlorine. Now let's know how this chlorine is prepared in the laboratory. Chlorine is prepared by treating potassium permanganate crystals with concentrated hydrochloric acid. Equation of this reaction is given as 2 KMnO4 plus 16 HCl gives 2 KCl plus 2 MnCl2 plus 8 H2O plus 5 Cl2. Now can you find out the reactants and products in this equation? Yes, you are right. Potassium permanganate and hydrochloric acid are the reactants and the products are potassium chloride, manganese chloride, water and chlorine. Do you know why this chlorine gas is passed through water? It's because to remove the traces of HCl vapors that comes out along with the chlorine. Did you see? The gas that comes out from the water is allowed to pass through concentrated sulfuric acid. Why is it so? It's because concentrated sulfuric acid can absorb the water vapor present in the chlorine gas. Understood? Now observe the picture. How the chlorine gas is collected in the gas jar? Yes, by the upward displacement of air, isn't it? From this, what can you understand about the density of chlorine? Absolutely, the density of chlorine is higher than that of air. That is why it is collected in this manner. Based on these observations, let us consolidate the physical properties of chlorine. Chlorine is a greenish yellow colored gas. It has a pungent irritating odor. The density of chlorine is higher than that of the air. Now shall we see the other properties of chlorine? Yes, we are going to discuss about the bleaching action of chlorine. For that, let us see an experiment. Fill chlorine gas in a round bottomed flask. Now show a wet moistened rose flower inside the flask. Close the mouth of the flask tightly. Did you see a gradual change in the color of the flower? Observe carefully. Yes, it's because of the bleaching action of chlorine. Chlorine gas has the capacity to decolorize wet objects. Let us learn about the chemistry of bleaching taking place here. The reaction of chlorine with the moisture is given as Cl2 plus H2O gives HCl plus HOCl. In this equation, the product HOCl, hypochlorous acid, is unstable and hence it decomposes as HCl and O. The nascent oxygen formed due to decomposition oxidizes the colored objects to make them colorless. This is the basis of bleaching activity of chlorine. It is said that the bleaching activity of chlorine is an oxidation reaction. Do you know the reason? As you saw that chlorine needs moisture for its bleaching action, right? The formation of nascent oxygen is responsible for the bleaching nature of chlorine in the presence of moisture. Understood? That is why the bleaching activity of chlorine is said to be an oxidation reaction. Now it's clear that the bleaching activity doesn't happen in the absence of moisture. In the next video, we will learn about the uses of chlorine and identification of chloride salt. So please watch the next video.